Hi everyone, I am R.Bhuvaneshwari, Assistant Professor of Computer Science, A.D.M. College, Autonomous, Nagapattinam. Today my topic, Digital Electronics with a Logic gates. Logic gates are the fundamental component of all digital circuits and systems. In digital electronics, there are 7 major types of logical gates used to perform various logical operations. The logic gate is basically an electronic circuit designed by using components like diodes, transistor, resistor, capacitor, etc. and capable of performing logical operations. In this article, we will study the definition, truth table and other relational concept of logic gates. So, let's start with the basic introduction of logic gates. What is the logic gate? A logic gate is an electronic circuit designed by using electronic components like diodes, transistors, resistors and more. As the name implies, a logic gate is designed to perform logical operations in digital systems like computers, communication system, etc. Therefore, we can say that the building blocks of a digital circuit are logic gates, which execute numerous logical operations that are required in any digital circuit. A logic gate can take 2 or more inputs, but only one output. The output of a logic gate depends on the combination of input and the logical operation that the logic gate performs. Logic gates use Boolean algebra to execute logical processes. Logic gates are found in nearly every digital gadget we use on regular basis. Logic gates are used in the arithmetic of our telephone, laptop, tablet and memory devices. Type of logic gates. A logic gate is a digital gate that allows data to be manipulated. Logic gates use logic to determine whether or not to pass a signal. Logic gates, on the other hand, give the flow of information based on a set of rules. The logic gates can be classified into the following major types. One is basic logic gates. There are 3 basic logic gates: AND gates, OR gates and NOT gates. The second one, universal logic gates. In digital electronics, the following 2 logical gates are considered as universal logic gates. One is NOR gate and second one NAND gates. And third one, derived logic gates. The following 2 are the derived logic gates used in the digital system: XOR gate and XNOR gate. Let us now discuss each of these types of logic gates in detail one by one. First one is AND gate. In digital electronics, the AND gate is one of the basic logic gates that perform the logical multiplication of inputs applied to it. It generates the high or logic 1 output only when all the input applied to it are high or logic 1. Otherwise, the output of the AND gate is low or logic 0. Properties of AND gate. The following 2 main properties of AND gate. The first one is AND gate can accept 2 or more than 2 input values at a time. When all the inputs are logic 1, the output of the logic is 1. The operation of AND gate is described by a mathematical expression which is called the Boolean expression of the AND gate. For two input AND gate, the Boolean expression is given by, for example, Z equal to A into B, where A into B are input of the AND gate, while Z denote the output of the AND gate. Truth table of AND gate. The truth table of AND gate is given 2 input. One is A and another one is B. 0 and 0 is a AND gate produce the output 0, and 0 and 1 is produce the output 0. 1 and 0 produce the output 0. 1 and 1 produce the output 1. Symbol of AND gates. The logical symbol of a 2 input AND gate is shown in the following figure. For the 2 inputs of A and B produce the output A into B. Next one, OR gate. In digital electronics, there is a type of basic logic gate which produces a low or logic of 0 output only when it is all inputs are low or logic 0. For all the input combinations, the output of the OR gate is high or logic 1. This logic gate is termed as OR gate. An OR gate can be designed to have two or more inputs but only one output. The primary function of the OR gate is to perform the logical sum operations. Properties of OR gate. An OR gate have the following two properties. And first one, it can have two or more input lines at a time. And second one, when all of the inputs toward the OR gate are low or logic 0. The output of is low or logic 0. The operation of an OR gate can be mathematically described through a mathematical expression I called Boolean expression of the OR gate. The Boolean expression of the two input gates as Z equal to A plus B. The Boolean expression for a 3 input OR gates, for example, Z equal to A plus B plus C. Here, A, B and C are input and Z is the output variable. We can extend this Boolean expression to any number of input variables. Truth table of OR gate. The truth table of an OR gate is described the relationship between inputs and outputs. The following is the truth table of the two input OR gate. There are two input OR gates. First one A and the second input is B. Produce the output A or B. 0 and 0 produce the output 0. Input 0 and 1 produce the output 1. Input 1 and 0 produce the output 1. Produce the input 1 and 1, 1. Symbol of OR gate. The logic symbol of the two input OR gates is shown in the following figure. For example, logic gates, simple A and B, two inputs, produce the output Z equal to A plus B. NOR gate. The NOR gate is a type of universal logic gate that can take two or more inputs but only one output. It is basically a combination of two basic logic gates, that is OR gate and a NAND gate. Thus, it can be expressed as NOR gate equal to OR gate plus NAND gate. In other words, NOR gate is an OR gate followed by a NAND gate. Properties of NOR gate. The following are the two important properties of NOR gate. A NOR gate can have two or more inputs and gives only one output. A NOR gate gives a high or logic 1 output only when its all inputs are low or logic 0. Similar to basic logic gates, we can describe the operation of the NOR gate using the mathematical equation called the Boolean expression of the NOR gate. The Boolean expression of two input NOR gate is given below. C equal to A plus B the whole bar. We can explain this expression to any number of input variables. In the above Boolean expression, the variable A and B are called input variables, while the variable C is called the output variables. Truth table of NOR gate. The following truth table of a two input NOR gate showing relationship between its input and outputs. These truth table, A and B are two inputs. 0 and 0 produce the result 1. 0 and 1 produce the result 0. 1 and 0 produce the result 0. 1 and 1 produce the result 0. This is the NOR gate logic diagram. Two inputs and produce the outputs. NAND gate. In digital electronics, the NAND gate is another type of universal logic gate used to perform logical operations. The NAND gate performs the inverted operations of the AND gate, similar to NAND gate. The NAND gate can also have two or more input lines but only one output line. The NAND gate is also represented as a combination of two basic logic gates, namely AND gate and NOT gate. Hence, it can be expressed as NAND gate equal to AND gate plus NOT gate. Properties of NAND gate. The following two key properties of NAND gates. First one, NAND gate can take two or more inputs at a time and produce only one output based on the combination of inputs applied. Another one is NAND gate produces a low or logic 0 output only when its all inputs are high or logic 1. We can describe the expression of NAND gate through a mathematical equation called its Boolean expression. Here is the Boolean expression of two input NAND gates, C equal to AB. In this expression, A and B are the input variable and C is the output variable. We can extend this relationship to any number of input variables like 3, 4 or more. Truth table of NAND gate. The truth table is a NAND gate. Inputs describe the operation of the NAND gates and so below. Two inputs A and B produce the output. 0 and 0 produce the output 1. 0 and 1 produce the output 1. 1 and 0 produce the output 1. 1 and 1 produce the output 0. Symbol of NAND gate. The logic symbol of a NAND gate is represented as AND gate with a bubble on its output and described in the following figure. This is the symbol of two input NAND gates. For example, logic gates. Two inputs of logic gate produce the output one logic gates. XOR gate. In digital electronics, there is a specially designed logic gate named XOR gate, which is used in digital circuit to perform modulo sum. It is also referred to as exclusive OR or EXOR gate. The XOR gate can take only two inputs at a time and give an output. The output of the XOR gate is high or logic 1 only when it is two inputs are dissimilar. Properties of XOR gate. The following two are the main properties of XOR gate. First one is it can accept only two inputs at a time. There is nothing like a 3 or more input XOR gate. Second one, the output of the XOR gate is logic 1 or high when its inputs are dissimilar. The operation of the XOR gate can be described through a mathematical expression called its Boolean expression. The following expression XOR gate is Z equal to A plus circle B. Here Z is the output variable and A and B are the input variable. This expression can be written as follows. Z equal to A bar B bar plus AB bar. Truth table of XOR gate. The truth table is the table of inputs and outputs that describe the relationship between them and the operation of the XOR gate of different input combinations. The truth table of the XOR gate is given below. Two inputs A and B. Inputs 0, 0 produce the output 0. Input 0 and 1 produce the output 1. Input 1 and 0 produce the output 1. Input 1 and 1 produce the output 0. Symbol of XOR gate. The logic symbol of the XOR gate is following figure. Input two input A and B produce the output Z. XNOR gate. The XNOR gate is another type of special purpose logic gate used to implement exclusive operation in digital circuit. It is used to implement the exclusive NOR operation in digital circuit. It is also called the EXNOR or exclusive NOR gate. It is a combination of two logic gates, namely XOR and NOR gate. Thus, it can be expressed as XNOR gate equal to XOR gate plus NOR gate. The output of an XNOR gate is high or logic 1 when it is both inputs are similar. Otherwise, the output is low or logic 0. Hence, the XNOR gate is used as a similarly reductor circuit. Properties of XNOR gate. The following are two key properties of XNOR gate. First one, XNOR gate take only two inputs and produce one output. And second one is the output of the XNOR gate is high or logic 1 only when it is similar inputs. The operation of XNOR gate can be described through a mathematical equation called the Boolean expression of XNOR gate. Here the following expression of the XNOR gate as Y equal to A dot circle B and another one is Y equal to A dot B circle. We can also write this expression as follows. Y equal to AB bar plus AB. Here A and B are inputs and Y is the output. Truth table of XNOR gate. The truth table of XNOR gate is given below. This truth table is describing the relationship between input and output of the XNOR gate. This is the truth table of XNOR gate. Two inputs A and B. Input values are 0 and 0, produce the output 1. Input values of 0 and 1, produce the output 0. Input the values of 1 and 0, produce the output 0. Input the value of 1 and 1, produce the output also 1. Symbol of XNOR gate. The logic symbol of XNOR gate is shown in the following figure. Here A and B are inputs and Y is the output. This is the logic case. Boolean algebra. The Boolean logical symbol of 0 and 1 are used for representing the digital input or output. The symbol 1 and 0 can also be used for permanently open and closed digital circuit. The digital circuit can be made up of several logic gates. To perform the logical operation with the minimum logic gates, a set of rules were invented known as law of Boolean algebra. These rules are also used to reduce the number of logic gates at performing logical operations. The Boolean algebra is mainly used for simplifying and analyzing complex Boolean expression. It is also known as binary algebra because we only use binary numbers. In the geography developed the binary algebra in 1854. Rules in Boolean algebra. First rule, only two values 1 for high and 0 for low are possible for the variable used in Boolean algebra. The overbar is used for representing the complement variables. So, the complement variable is represented as. Third, the plus operator is used to represent ORing the variables. Fourth one, the dot operator is used to represent ANDing of the variable. Properties of Boolean algebra. First one, commutative law. This law states that no matter in which order we use the variable, it means the order of the variable does not matter in this law. For example, A into B equal to B into A. Another one is A plus B equal to B plus A. And next one, associative law. This law states that the operation can be performed in any order when the variable priority of the name as multiplication and slash. For example, A into B into C equal to A into B into C. Same as A plus B plus C equal to A plus B plus C. Descriptive law. This law allows us to open up brackets. Similarly, we can open the brackets in the Boolean expression. A plus B bracket B into C equal to A plus B dot A plus C. At the same time, A dot B plus C equal to A dot B plus A dot C. Boolean function. The binary variables and the logic operations are used in Boolean algebra. The algebra expression is known as Boolean expression. It's used to describe the Boolean function. The Boolean expression consists of constant values 1 and 0, logical operation symbols and binary variables. Example 1, f equal to x bar into z plus b. We defined the Boolean function f equal to xy bar z plus b in terms of four binary variables x, y, z and p. This function will be equal to 1 when x equal to 1, y equal to 0, z equal to 1 or z equal to 1. That's all.